Welcome to Inside Insights, your quick hit of tips, tools, and trends for manufacturing, distribution, and Dynamics 365 Business Central, brought to you by InsightWorks.
Welcome back to the Deep Dive, where we take stacks of sources, chew them up, and serve you the most essential nuggets of knowledge. If you are deeply involved in manufacturing, and whether you're a planner, an operations manager, or you're running the shop floor, you know this specific brand of pain. You spend hours, maybe days, building this logical, really optimized production plan. You print it out, you release it to the floor, and within, 24 to 48 hours, that beautiful plan has completely dissolved. It's just a mess of backlog, expediting, and frantic rescheduling. So our mission today is to dive deep into that operational disconnect. Why do the plans fail even when all the data seems right? We are targeting the fundamental flaw baked into most scheduling logic, this deeply held and very costly assumption of infinite capacity. We'll explore what that costs your business in real dollars, and then crucially, we'll show you how specialized tools can integrate with platforms like Microsoft Dynamics 365 Business Central to bridge this huge gap between the schedule and, reality. If your team is stuck in a permanent cycle of firefighting instead of actually executing, this deep dive is custom tailored for you. We are solving that core problem right now.
And what's fascinating here is that when manufacturers talk about scheduling failure, they often blame human error or maybe some unexpected event. But the research shows the issue isn't human. It's foundational. It's the software's whole operating philosophy. It's like, well, that's just wrong.
And that philosophy has a name, right? The myth of infinite capacity. We are talking about scheduling tools that, at their core, just assume you have unlimited availability of every single resource, machines, labor, tools, all of it. So if the math says a job needs to start Tuesday at 9 a.m., the software it assumes the resources are there. It doesn't care if that machine is already running another job or if the technician called out sick.
And if we connect this to the bigger picture, the consequence is, well, it's devastating for predictable manufacturing. This theoretical planning approach immediately throws your entire production team into what we call a permanent firefighting mode. They end up spending more time reacting to every single delay, every breakdown, and every labor shift change than they do actually executing a plan. The inefficiencies here, they aren't just frustrating, they translate directly to the bottom line. Our sources highlight several key costs. We're talking massively increased operational overhead, primarily due to emergency overtime, excessive inventory buffers that are built just to hedge against these internal delays, and critically, the inability to reliably meet promised delivery commitments.
You can't keep customers happy if your internal schedule is fiction.
Not at all.
So if that's the pain, what exactly is it that standard scheduling tools are lacking? Because most systems track machines and labor, don't they? What are the specific real-world constraints they just can't model?
They lack the ability to model constraints as finite. That's the key. We've identified 3 critical areas that standard scheduling systems they routinely ignore them or simplify them so much they become useless. First, they ignore machine downtimes. That includes scheduled preventative maintenance, necessary clean-out windows between different materials, and even simple mandatory shift changes. The standard tool sees a machine as 247 capable, if that's how it's defined in the work center. It doesn't factor in the 6 hours a week it's down for service.
Right. They see capacity as just a steady line on a graph, not a fluctuating resource with hard stops.
Exactly. Second, they fail on labor availability and required skills. It's not enough to know you have 10 employees on the floor. You need to know if they're certified to run the CNC machine or if they're trained on the new welding robot. If the schedule calls for a certified welder and that welder is already busy on another job, the schedule is instantly broken. But the standard software, it doesn't flag that conflict.
That's a huge distinction. It's not just human versus machine. It's the right human for the right machine.
Precisely. And the third failure point is setup times and sequencing costs. Standard systems often schedule jobs in an order that maximizes capacity, mathematically, but it leads to physical chaos. Imagine running a machine that needs a 4-hour teardown and setup every time you change a color or material. If the software schedules a run of blue, then red, then blue again, you're just repeating that costly 4-hour setup for no good reason. Standard scheduling just can't natively optimize for minimizing those sequential setup costs.
Okay, so let's focus this specifically on our audience who are working inside Dynamics 365 Business Central. It's a powerful ERP, but what does this infinite capacity assumption actually look like when they open the software? How does Business Central handle scheduling, and where does it fall short?
Well, Business Central provides a really solid foundation. It uses routing definitions to dictate the sequence of steps a product takes, and work center definitions to identify the machines and labor involved. And it gives you estimated run times. It calculates all the necessary production dates based on that data.
Which, that sounds perfect on paper, so what's the catch?
The catch is that inherent assumption of infinity. When the schedule is calculated, if, say, 3 high-priority jobs all need machine A on Thursday morning, the system will mathematically schedule them all to start at the exact same time. If you look at the resulting Gantt chart in a standard BC environment, you might literally see 4 jobs layered on top of each other at the same workstation. It works for the system, mathematically, but it's physically impossible for your shop floor.
Wait, so you're telling me the system knows the machine exists, it knows the routing, but it just ignores the physical limitation of one machine running one job at a time?
It doesn't ignore the existence of the machine, but it prioritizes the date and the demand over the physical limits of capacity. And this leads directly to the next huge point: manual sequencing. Because the schedule that Business Central produces is theoretical, the planners are forced to manually sequence the jobs. They have to drag and drop tasks based on tribal knowledge or, spreadsheets just to make the timeline physically possible.
Okay, but if manual sequencing is so bad, why do so many highly experienced companies still swear by having a senior planner manage the board with Excel or even physical whiteboards?
That's the trap, right?
Yeah.
They trust the experienced planner more than they trust the faulty automated schedule. But manual sequencing is incredibly vulnerable. It fails because that planner, no matter how good they are, cannot possibly account for 2 crucial things in real time. First, they can't dynamically model alternative routing options. Often a job could move from machine A to machine B, but the planner rarely has the time or the data structure to check if that's feasible and adjust the whole sequence instantly. And second, they just can't account for real-time shop floor conditions. When a machine breaks or the parts arrive late, that planner's manually sequenced schedule is immediately obsolete. They have to stop everything they're doing and resequence, which is time-consuming, it's error-prone, and it burns management hours that should be spent on optimization, not triage.
And what we found in the research really confirms that. Standard Business Central, while it's robust in financials and inventory, offers very little native support for this crucial feedback loop. You can't easily see a visual map of where the conflicts are or where the next bottleneck is going to form. It's all just dates and numbers. This brings us to 3 major misconceptions we really need to dismantle for our listeners. These are the beliefs that keep operations managers stuck in that reactive cycle. The first one is the idea that your standard ERP scheduling tools, and that includes Business Central, are inherently smart enough to handle all those granular, finite constraints like maintenance, labor skills, or setup minimization automatically. Spoiler alert, they aren't. They give you a schedule based on ideal conditions. You have to accept that the struggle you're having is a tool limitation, not a personal failure.
And I'd add that this feeds right into the second misconception. Believing that relying solely on manual sequencing or having that highly experienced planner with a massive spreadsheet adequately compensates for the tool's limitations. The research calls this out as an exponential risk. Every single manual override introduces the chance for human error. And when you have thousands of operations moving across hundreds of work centers, well, the resulting errors compound incredibly fast.
It's like trying to pilot an airplane by manually adjusting every single control surface based on wind speed readings you took 5 minutes ago. You're just constantly behind the curve.
Exactly. And the final misconception is treating scheduling as a static, one-time activity. You print the schedule, you post it on the wall, and you consider the job done. The source material really emphasizes this. The shop floor is a dynamic environment. Parts arrive late, employees get sick, quality issues pop up. If your schedule isn't built to absorb and instantly adjust to those changes, it's useless by lunchtime.
So, if standard tools fail because they live in this world of infinite possibility, what does an effective finite capacity scheduling system, an FCS system, actually look like when it's successfully applied?
It looks like physics applied to software. An FCS requires tools that model your actual constraints, the real limits of machines, the limits of labor, and the necessary sequential rules to generate a truly executable schedule. This means 2 things are basically non-negotiable for effective FCS. First, the system has to consider resource availability, setup optimization, and crucially, it has to automatically look for alternate routing options. So if machine A is booked solid for the next 2 days, the system has to dynamically check if the job can run on machine B instead, factor in any different setup time that might require, and then automatically adjust all the subsequent jobs in the sequence.
That sounds like moving from playing chess in the dark to having a full digital simulator where you can see the consequences of every move instantly.
That's a great analogy. And second, to make this actionable for planners, FCS requires robust visual interfaces. Planners need a live graphical view, a digital Gantt chart that clearly shows workload distribution, flags conflicts before they happen, and updates instantly as production status changes. This visual support shifts the planner's job from data entry and error correction to strategic decision-making.
And this brings us right to the specific solution highlighted in the source material, which is designed to integrate this finite capacity modeling directly into the ERP environment our listeners are already using. InsightWorks' MXAPS application. MXAPS is designed specifically as an integrated finite capacity scheduler within Business Central. And for those wondering, APS stands for Advanced Planning and Scheduling. This isn't some separate program bolted on. It speaks the same language as your existing inventory, routing, and work center data, which eliminates all those painful integration steps.
Its core function is solving that infinite capacity problem. It automates scheduling by incorporating those real machine and labor constraints that we found were missing in the native BC system. It shifts the entire mindset from when should the job start to when can the job actually start. One of the most valuable features the research emphasizes is the support for what-if scenario modeling. When a planner learns that a critical CNC machine is going down for emergency repair, they don't have to panic. They can model that machine being unavailable for 8 hours, see the ripple effect across the entire shop instantly, and then try alternate solutions like shifting the workload to a backup machine or scheduling overtime before they commit to a single change.
That's powerful. So instead of guessing and hoping, you can actually test the solution in a safe digital environment first.
Absolutely. And all of this is supported by those graphical tools we talked about, allowing for easy drag-and-drop schedule adjustments after the system has presented the optimized solution. The overall outcome is, well, it's profound alignment. You are aligning the theoretical plan perfectly with the physical shop floor realities. And that fundamentally reduces manual sequencing time, it minimizes reactive changes, and it gives managers real confidence in their promised delivery dates.
We've had a really detailed look at the mechanics and the solution. Now let's zoom out a bit. If you are a manager or a planner, and you're evaluating your next steps, either upgrading or adopting a new scheduling solution, what are the 5 concrete must-have factors you should be prioritizing?
Okay, first, you have to scrutinize the degree to which any system models finite resources. And this isn't just machines. Remember, it has to include both machines and specialized labor. A system that only handles one is only a partial solution.
Don't settle for half capacity. Got it. What's number 2?
Second, you have to demand the availability of alternative routing options. If your schedule breaks, the system needs to have the intelligence to automatically find and assess viable backup paths. The intelligence of the system is really measured by its flexibility when things go wrong. Third, because the environment is so dynamic, look for systems that require and use real-time production status updates for accuracy. If the schedule is calculated on data that's 10 minutes old, it's already less accurate than it should be. Integration with shop floor data is paramount.
Fourth, and we've covered this, but it really bears repeating, visual tools are non-negotiable. If your planners are just staring at columns of spreadsheet data, they are losing critical seconds needed to spot and correct conflicts. You need graphical representations to highlight bottlenecks and workload conflicts visually.
And finally, assess the automation capabilities, specifically for sequencing and for scenario analysis. Automation is what frees your highly paid, experienced planners from all that manual drudgery and lets them move into optimization.
So what does this accumulation of knowledge mean for you, the listener? Let's talk about how this actually impacts your day-to-day operations, moving beyond just the technical specs. For production planners, this deep dive should provide immense clarity. You now have a clear understanding of the limitations that are just inherent in standard Business Central scheduling. That frantic rescheduling. It wasn't your fault. It was a tool limitation rooted in a bad assumption. Finite capacity scheduling capabilities, like those offered by MXAPS, offer the practical alignment you need. This means reliable, executable plans, not theoretical dreams. You get your time back.
And for operations managers, this fundamentally changes the way you manage people and assets. With a true FCS system implemented, schedules become predictable and consistently executable. The direct benefits are a massive reduction in the frequency of firefighting. Your team can now focus on continuous improvement projects rather than constant triage.
You gain better resource utilization because you're no longer overscheduling bottlenecks. You get improved delivery reliability, which means fewer unhappy customers and fewer penalty clauses. And critically, you get greater confidence in all your production planning decisions. This allows you to move from hopeful planning to evidence-based, data-driven execution. We started this deep dive with the pain of theoretical schedules based on infinite capacity, which constantly led to confusion and backlog. We've demonstrated how integrated tools use real constraints, not theoretical ones, to deliver executable, predictable plans. This shift from infinite possibility to finite reality is the core difference between planning and successful execution.
And we've thoroughly established that scheduling is not a one-time activity. It requires ongoing, accurate adjustment as shop conditions evolve. So now, consider this final provocative thought. If integrating finite capacity scheduling suddenly provides you with reliable, predictable production timelines, meaning you know exactly when a job will finish and which resources it will consume, what critical non-scheduling decision in your business, like determining ideal procurement lead times or establishing inventory buffering strategies, suddenly becomes easier to optimize? Think about how scheduling confidence fundamentally changes your entire operational strategy.
That is a fascinating next deep dive. Thank you for taking this journey with us. We'll see you next time.